This week on Quality Digest Live, we chat with Zhou, Executive Technical Leader for Global Quality at the Ford Motor Company.
Plus, could Florence Nightingale have been history's first black belt? We'll find out when we come back.
This week's sponsor of Quality Digest Live is TÜV Südamerika. Take a minute to check out TÜV Südamerica's free QMS webinar series at www.tuvamerica.com/QMS webinars.
Well, welcome back to Quality Digest Live for December 7th, 2012. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Quality Digest publisher Mike Richmond. Dirk, welcome back to the show.
Thank you, thank you.
It's good you could be here with us today.
Hey, well,
appreciate
I had
that.
a nice vacation.
Yes,
It was cool.
I'm sure you did. Good, thank you.
You guys did great.
We did, yes. Ryan Day filled in nicely in your very large shoes, but it was
Thank you.
fun to do that. Okay.
Size 8s.
Well, you know, Dirk, we got a very, very, very full packed show today with a lot of good interviews, articles, and a terrific tech corner. So we're going to dispense with the news just for this week, and we're going to jump right into our feature stories. Okay. First up is a piece that appeared in Wednesday's issue of Quality Digest Daily. Excellence is not an event, it's a habit, by Dr. Zhou, who is Ford's Executive Technical Leader for Global Quality. Dr. Zhou's article neatly addresses an issue that many of you confront, namely how organizations can establish a unified culture of quality across the enterprise. This is a particularly important topic for those companies like Ford, with operations, partners, suppliers, and customers across the globe. So to address these issues more deeply, we're very, very pleased now to be joined by Dr. Zhou. We're going to welcome him to the show via Skype. Dr. Zhou, are you with us?
Okay, hi, Mike, and hi, and Dirk, and nice to see you on this camera.
Yeah, how are you doing today?
Great, great. How about you?
Oh, we're doing great here.
We're doing great. Well, we want to jump right into it, Dr. Zhou. I want to ask you a little bit about your article. In the piece, you talk about the infrastructure, the processes, the time and data management, and the tools of quality. Now, how do you communicate all this information through a vast enterprise like Ford that spans very many different nations and cultures? Okay.
Mike and Dirk, first I want to thank you for having me on the program. Also thank the audience and the viewers on this program. At the Ford, we do these things by standardize the quality operating system. By standardize the information flow, I mean we collect voice of customers in a standard way. And then we organize, prioritize, use those feedback in a standard way. And secondly, by infrastructure, we mean we have a standardized team structure. For example, we have a variability reduction team at every plant and every facility we build vehicles. Then we also have a standardized vehicle functional group at every engineering centers. By a standardized time and data management, I mean we have a standardized meeting cadence. For example, planned quality meeting every day, and the product development quality review every week. We have a standard agenda and the meeting cadence and so forth. By standardize the process and the tools, that means, for example, we have a global product development system. Now we also have a standard tools for problem solving, for example, DMAC. So that's how we communicate with all of the facilities around the world. So we use the standardized quality operating system.
Well, Dr. Zhou, I mean, one thing that interests me on this, though, is so you have plants all over the world. You have plants in China, you have plants in the United States, plants in Italy, and so forth. How do you, I guess what I'm curious about is, aren't there cultural differences so that when you're trying to introduce or talk about these standards, do you have to present them in a different way, let's say in China, than you might present them in the United States, just given cultural perceptions, cultural differences?
No, we present them to every trip or every review we have. Basically, it's the journey of learning and teaching and applying. And then our quality operating system basically is a standardized dictionary. So we talk in the same language, and of course the speaking language is different. But our quality operating system is the standard dictionary. So therefore, no matter which country or which market or which facility, we communicate in the review and the teaching and whatever. So we have a standard dictionary. So therefore, we just make sure we make it relevant to the customer over there and their usage, their environmental conditions, and so forth. Okay. To make it, go ahead.
Could you maybe give us an example of a best practice, perhaps, that you shared from one plant in one part of the world that you brought to another plant in another part of the world, or to all of your plants, perhaps?
Yeah. So then, give an example. Let's say for the air leakage tester, right? So we have air leakage testing for the equipment at every plant, and then we do that since in the same way. Maybe first time one plant did that, and then we replicate it to other plants. And another example was headlamp leak test, right? So we come out the way and we put the headlamps in the water tank, right? Then we see where's the bubble, right? Then doing that, and then we standardize that method, and then we share with all of the facility around the world.
Okay, now, Dr. Zhou, I know one thing that's really important to Ford is listening to your customers, obviously the voice of the customer. Now, is that done, is the customer feedback and how that works into your suppliers and so forth, is that unique to each country? So in other words, voice of the customer in the United States might be different than the voice of the customer in Italy, voice of the customer in China, and so forth?
Yeah, the voice of the customers in different regions or different countries might be different, but we have a standardized way to collect voice of a customer. For example, we have a so-called global quality research system to collect voice of a customer or voice of a customer feedback at the different markets. For example, North America, South America, Europe, Asia Pacific, and Africa. So we have a standard way to collect the voice of our customers, and then therefore we know what difference between the different countries and then what's the difference in the voice of a customer.
And I think when we were talking the other day, you gave me a couple of good examples of how things that might be important in one country or maybe not important in one country are important in the other, just based on the differences in how they use your vehicles. Now, you mentioned something about horns and I think windows. Can you tell us those stories again?
Yeah, so for example, in India or in China, right, the customers over there use the horns quite often.
Oh, the horns, they're car horns.
Yeah, right.
Yeah, car horns, like in the US, right? And then I forgot when was the last time I used the horn.
In the US, right?
In the US, yeah. But the customer over China and India, they use that quite often. Another example is, for example, in China, they use they open the window and quite often because there are lots of toll booths on the highway, right? So that's those the unique difference and customer usage.
So what you're saying is that things like horns and windows, where we may not use them quite as vigorously in the United States, in other countries like China or Malaysia or whatever, they're always using the horn. They're rolling down the windows, like you said in China, a lot for toll booths. So those windows and those horns have to be, what, more robust or tested more, or how?
So therefore we have to design our system to meet the customer's requirements over there. So that's kind of a feedback process, right? We listen to the customers, then we translate the customer voice of the customer into the engineer specification, then we design to the specification. Therefore, we meet the customer needs over there.
Okay.
Dr. Zhou, many of our readers and our viewers are operating internationally, of course, and you, in your position with Ford, of course, have a great insight into best practices in terms of working internationally. What would you say are some of the most important things that our users should know about operating in terms of process, in terms of suppliers, customers in different countries across the world?
Yeah, so for me, it's first to listen to the people over there, and then seek to understand what they mean and what's their needs and what's their want, and therefore then work with them closely and try to engage and make everything resonate as much as possible, relevance, and make a reference to them, to the customer, to the people, or our partners, suppliers, dealers, engineers over there. Make it as relevant as possible. Seek to understand what they mean.
When you say stay relevant, I mean, I guess obviously you're talking about voice of the customer, and you're talking about asking, kind of very, very penetrating questions. What are some of the ways that you would do that? I mean, it's from a distance, it can be difficult. Do you have to rely on your partners in those areas?
Yes, and then of course we have a global team, and we also have a regional quality team, also regional in the plant and the suppliers and so forth. So just to stay connected with them and understand the cultures over there, understand the customers over there, understand the environment conditions over there, understand even government regulatory requirements over there. Just try to understand the situation over there. Then you work with them and speak with them and communicate with them. Then you make it more relevant, and then you are not like just come from the U.S. and talk the language they don't understand, and I don't understand them. So just make to learn from each other, apply together. So that's one of the experience I learned over the last 10 or 20 years with the Ford Motor Company.
Okay, well, Dr. Zhou, thank you for joining us today. Our time is up. I really appreciate you taking your time out of your busy schedule to join us.
Thank you, Derek, and thank you, Mike, and also thanks to the viewers and the audience on this program. Thanks.
Okay, thank you.
Thank you for joining us. Good stuff there with Dr. Zhou.
So important to basically important to understand the cultural differences.
Yes.
If you're a multinational country and a company, you need to understand your culture.
That's great. We've really we've had Ford guests on the show now a few times in the past several months, and it's really nice to get the perspective of a company like Ford,
right?
A power user of systems like Ford, to understand what they're doing and how they're doing it, because I think our users can benchmark against companies like Ford.
Yeah, absolutely.
In many ways. So we're going to continue to hopefully work more closely with Ford in 2013. So you can expect more pieces on this show and in QDD from the good people at Ford.
Right. Well, there was a fascinating article by Matthew Barsalou this week on Florence Nightingale. Now, most of us, like me, Nightingale was, we learned about Florence Nightingale in school and kind of figured she was like kind of founding the field of nursing, the mother of modern nursing. Yeah. But few people outside the field of mathematics know about her contributions to statistics during the Crimean War. So here's a little bit of history. The Crimean War was waged from October 1953 to February 1856. And basically the scene was to support Turkey in a war against Russia. England and France had invaded the Crimean Peninsula. Now, the French had sent nurses to care for their wounded, but the British troops did not even have material to make bandages. So Nightingale was sent to the Crimea to train and lead a group of nurses at the Scutari military hospital. So when she arrived there, she found a mortality rate of, get this, 42%. Almost half the people who went to the hospital in Scutari died. She reported that the hospital was filthy, wind was blowing air out of the sewers into the areas with patients, laundry was washed in cold water, and many supposedly clean blankets needed to be destroyed because they were still infested with parasites after washing. Now keep in mind, this is the mid-1800s, so this is kind of before or around the time where links between cleanliness and illness were being investigated by Louis Pasteur, James Lister, right? So This is kind of, I guess, it kind of surprised me that it was that late, but I realized that, yeah, Pasteur and Lister, all these guys were going, wait a minute, you got to clean wounds, you got to have a sterile environment if you want people to survive. That still really wasn't well known, and this was kind of the milieu that Florence Nightingale was thrown into. Mm-hmm. She must have known some of this stuff, though, because she is the one who reported on the conditions and the understanding that these conditions were leading to the mortality rates at these hospitals.
Well, what she understood is she understood that there was a statistical a piece to this that needed to be understood.
That she could understand.
That she could understand, that could help her reach a solution to this.
Exactly. And by the way, Florence Nightingale was the first woman to be inducted into I think it's the UK or the British Statistical Society. Mm-hmm. So she was a statistician. She actually created something called the Rose chart by kind of a nickname. It's actually a polar chart. Mm-hmm. I think we have an image of it here.
You can see right there.
And basically what this is, it's kind of a combination between a pie chart and a stacked bar chart. Mm-hmm. So you probably can't really see it on your screen. Each slice of the pie represents a month, mm-hmm. and then with each month is a stacked bar chart representing the incidence of different types of mortalities within a particular hospital at a particular time and that sort of thing. And this was really used to help her to drill down into what the issues were and whether her actions were having an impact or not.
An effect, exactly right.
Yeah.
And I think you stated it really well that this mortality rate was horrific. It was almost half the people that went into the hospital died. I mean, they were safer.
They were safer on the battlefield.
In the trenches than they were.
If you had your hand blown off, it was kind of like,
you were better off.
Slap a bandage on it, I'm okay.
You were better off staying in the trenches with a blown off hand than going to Scutari Hospital and dying.
Well, her reforms, kind of finish up on this, her reforms implemented by Nightingale reduced the death rate from 42.7% of all patients admitted to Scutari to 2.2% with only two months.
In 2 months.
The head medical officer for the Army claimed the improvements were the results of healthier soldiers coming into the hospital, so Nightingale did some statistical analysis, mm-hmm. and she compared the death rate of soldiers to wounded and transported to the hospital to other patients in other hospitals in England, mm-hmm. and showed that no, the severely wounded died at a rate of 2.7%, not 42%. It was because of the change in the hospitalization there at Scutari. So pretty amazing stuff here. So
it's amazing, and you think about this. She had help, and she did. There was a gentleman that was referred to in the article, and I'm sorry I didn't catch the name, but it is in the article, so read that. Yeah. But there was a statistician that she brought in, that helped her to kind of interpret the data. But really the moral here is that statistics have real meaning, and you can derive real meaning from these things. And she understood it, 150 years ago during a horrific war, and made a lot of impact, and as you say, was inducted into the Statistical Society of England.
The British hospital system was really in need of an enterprise quality management system.
They were, and it's good that you say that, because
strangely enough,
were they able to come forward to next week?
They would have been interested in our next story. In our next story
and our next webinar, but I'm going to let you talk about it, Dirk.
Okay. Well, management is under pressure today, as all of you know, more pressure than ever to deliver better margins, greater revenue, and increased cash flow to support product research and improve shareholder value. Now, this cuts across all industries. What we've seen in the electronics and high-tech industries, for instance, is a lot of growth. In-house growth through R&D and growth through let's say, acquisitions and divestitures. So as a result, companies have inherited a lot of different systems, processes, and cultures that have to be harmonized. The key to operating efficiency is gaining this harmonization, pulling all this data together, getting all your processes to communicate, sharing quality data, and so forth. This is where enterprise quality management systems come in. Joining us today to talk a little bit about EQS and some of the issues companies are facing is Mohan Ponnudurai. He is an industry solution director at Sparta Systems Product Management Group. Thanks for joining us today. Mohan, just jump right in on you there.
Thank you. How are you?
Good. How are you doing? Good afternoon.
Great. So, Mohan, describe to us briefly what are kind of the key issues that companies are facing today for lack of integrated quality systems and being able to tie into their, I think you call them pillar systems.
A lot of the companies, when they started the quality management system. It came out of necessity. So what happened is it was driven locally from a departmental level. So at the end of the day, it became a hodgepodge of manual systems, internally developed systems, standalone point solutions. So really, all the data is sitting in different silos of databases. So just like you talked about before, you have all the data sitting there, but if you can't use the data to provide the useful information to make timely decisions, that data is useless. So that is the main problem now. Again, as you said about the globalization and the broader supply chains and things, those components make these problems even greater, because now you have many more stakeholders that you have to deal with, more complex products, broader markets, and different demographics of customers. So now you have really exaggerated the problem by having those singular solutions. So that's the reason that we say that you need to have a fully integrated enterprise quality management system that links in with the other business critical functions or pillar systems. So this way you get the value and you get the useful information to make timely decisions.
And what are, when you say pull all this, when we were talking earlier at the top here, pulling all this data together, what is some of the data that might be kind of the most critical for companies at this juncture in order to make sure that they're reducing their risk and so forth?
Well, it's a very simple thing is, when you look at a typical manufacturer, there's a lot of suppliers. So there's a lot of incoming parts. There's a lot of moving parts going on before it goes into the final assembly or production. So when the incoming comes, there's some problem. Now you have to make sure that you have to quarantine it, contain it, find what the problem is, find the source of the problem, so you can determine how much of that incoming you can use, how much of that you have to return back. And when you return back, you want to make sure your ERP or the enterprise resource planning system knows what kind of accounting it has to do to get the credit for it. And at the same time, also let the manufacturing systems know, all right, I have X out of the Y amount of parts that is usable, so here you are, you can use it for production. Now, from the other side, now you have found the problem, you want to make sure that you want to determine what the problem is, what the root causes, what the corrective actions. Now you want to involve different areas of your groups. It could be product design group, it could be field service, it could be suppliers. So now all those people have to come in to join hands to create that cohesiveness to get the common solutions done. Now this is only one incident. Now multiply this by hundreds of suppliers and multiply this by dozens of products and different lot numbers and product numbers. Now you see what the problem that you have in your hands with all the different data sitting in different places.
So Mohan, you describe in your article a 5-step process for EQM, and to me when I read that I immediately of course thought of DMAIC. So talk a little bit about how EQM can integrate with some of the language of quality that many people might be familiar with, like Six Sigma as an example, or Lean, or ISO. How would it integrate with some of those methodologies?
Good question. When we talk about quality management and the business processes, what we really say is you want to have a system that is variable, that you can do different types of process workflow based on the problem you have at hand. So some of the low priority, low value problems, you may not have to go through all those multiple steps. So you can do a simple investigation, root cause analysis, find the actions, and you're done. But for more complex, high value, high critical items, like you said about DMAIC process, or the other one that is used for very frequently by the 8D or Six Sigma groups is the 8D process, which is, again, it's got more components to it. Is more detail, more process, more formalized steps that you go through. So you can determine, based on the business rules that is defined, what kind of process that you want to go through based on the problem at hand. So the idea behind the EQMS and providing this multitude of variability in workflow is so that one size doesn't fit all. It doesn't fit all for every problem. It doesn't fit all for every customer, every business. So you want to be able to do that configuration capability so that you can address different needs in a different way.
Great. Well, Mohan, thanks for that. We're going to move on here, but I really appreciate your time here today. We're going to be talking to you again in just a few days on Wednesday. Get a deeper dive into this topic in a webinar we're going to be doing with Sparta at 2 p.m. Eastern, 11 a.m. Pacific, and That's on the 12th. So we'll see you then, Mohan. Thanks again for joining us.
You're welcome. Looking forward to seeing you later.
Good.
Thank you. Bye-bye.
Talk to you soon. Bye. All right, great stuff. Yeah, so sign up for that webinar. Again, it's going to be on the 12th, next Wednesday at 2 p.m. Eastern, 11 a.m. Pacific. You'll be able to check that out and get into EQMS with Mohan, and Dirk will be co-hosting that with him. Okay, we're going to move on now to our tech corner. Really good tech corner we have today from Creaform. Their GoScan portable white, very fast portable white light scanner from Creaform. We're going to go to Dirk right now and show it off. So take it away, Dirk.
Well, thanks. I've been waiting to get a 3D scanner on the show forever, and Creaform stepped up and really appreciate it. This is the GoScan 3D white light scanner from Creaform, our friends north of the border up there in the province of Quebec. Bonjour, mes amis. Thanks for sending this to us. This is an entry-level product for Creaform, and by entry-level, what I mean is it is their lowest cost white light scanner. It has a little bit less accuracy, a little bit resolution, but that's okay because the market it's intended for doesn't really need high resolution, high accuracy. What they're looking for is the speed of use, speed of setup, and fast scanning, easy to use. So really we're talking, let's say, the pre-production folks, maybe a product development, product design, packaging, prototyping, that sort of thing, where they need quick and easy scans in order to verify or to test some of their designs, right? So before we get into actually how this works, I'm going to show you a couple things here. I'm going to tell you a little bit about how white light scanning works, just as kind of a primer. So if we can go to our gauge can here, what you can see is basically, this is your kind of what a typical white light scanner might have. Over here, we've got a projector. What this does is this projects a pattern onto the object to be scanned. Over here, we've got a camera and a camera. These two cameras triangulate on the dots being projected by the projector on the device. The combination of triangulation and looking at the deformation of those dots around the part give them enough information to reconstruct that part in 3D space. And that's basically how white light scanning works. Now, before we get into this, Creaform is positioning this scanner as the fastest white light scanner on the market, and there's a couple reasons for this. Let me just show you what we're going to scan today in our demo. We're going to be scanning this. This is kind of a vacuum formed part. It's got a lot of geometry on it. Notice I'm going to scan this without fixturing it. I'm just going to hold this and scan it. No fixturing. That is one of the hallmarks of all the Creaform products, not just the GoScan, is something called dynamic referencing, which means you don't have to fixture the part. So there's cost savings and time savings. Also with the GoScan, no post-processing. What you're going to see, I'm going to scan this part, I'm going to get a file that I can immediately export. No post-processing. And actually another little thing to point out, notice there's no targets on this, reflective targets. Some of you who've worked with photogrammetry or other types of white light scanning may have used reflective targets. Depending on the part that you're scanning with the GoScan, if there's enough geometry, enough uniqueness about the part, the GoScan doesn't need any targets. You can just scan. It will stitch together the scans based on the uniqueness of the geometry. Now, if this was a flatter part, didn't have as much geometry, then we would use your standard reflective targets like you normally would. So let's go ahead and set up for a scan here and see what this looks like. So if we go over to our software share here, just want to show you a couple things. I really only need to do two things. I need to select what kind of surface I'm going to scan. I have my choice of a uniform surface or a textured surface. This happens to be uniform. And I want to set up my surface detail resolution. This is set for 2 millimeters right now. I could go down to 500 microns or half a millimeter. Not really necessary for this part, so we'll leave it at 2 millimeters. I'm going to tell it scan, and we will get ready to scan this part. Just takes a second. And I'm going to show you what a scan looks like, and you're going to watch me just scan this very quickly. Here we go, and I am, let me get scan. Sorry, I have a loose cable here. Let me get that back in. My bad. And we'll just start the scan again. There we go. And okay, scanner's recognized. And here we go. I'm scanning. And notice how just very quickly I'm moving both the part and the scanner just to get a look at everything I need. I'm going to switch hands here, and we'll get the rest of this. And there we go. And we will scan the other part here. Get back in, and we will scan this side over here, make sure I caught everything. And oops, looks like I missed a section up in the corner. We'll just come around, make sure I get all that. There we go. Some of the light's reflecting off these bright lights here, but that was it. The scan is done. That took me, what, maybe 45 seconds to scan that part. At this point, I'm actually done. I could say export this part. So in less than a minute, I've scanned this part. I can export it as an STL file right now, and I'd be done. But let's take a look at what we actually have here. So I'm going to zoom in a little bit. Let's rotate around. No holes. Oops, I'm sorry, there are holes. Okay, well actually that's good. That'll show me, let me show you something here. So suppose you're done scanning your part and you see you've missed an area. Obviously I missed the whole right side of this. I'm just going to go back into scan. And I'm going to pick up those areas that I missed. So here we go. We'll lock on and I'm going to come over on this side and I will just, getting a lot of reflection off. Here we go. It's really bright here in the studio, so that, there we go. And I have caught those areas that I missed before. There we go. All right, so something about this I want to point out. Very often in scanning or other types of 3D metrology, if you do multiple scans, what you end up doing is having multiple layers of scans, which you then have to align and then mesh together. Here I don't. What happens when I pick this camera up for another scan, it simply aligns the camera to the part and picks up where it left off. And then I just go back in and fill in the holes. And now we're good. All my holes are filled in. I can rotate around this part. Looks like I got everything. Looks like I didn't miss anything. There we go. And we're good to go. So now all I have to do is save it out. So I say save. By default, it wants to save as an STL file. I have my choice of maybe 15, 18 or other types of files that I could save as. In any case, I save it. And I save it out, and then I just bring it into my, to whatever my favorite point analysis software is. Let's say bring it into Geomagic. This software, VX Elements, really is data acquisition. It's really intended just to bring the points in and export them out. After that, you're going to bring it into whatever software you normally would do your analysis with. Now, I mentioned that this is an entry-level product. So the resolution, the accuracy on this is about 300 microns per meter. And they recommended object size of, let's say, under 3 meters, under 10 meters. That's kind of what this is designed for. Now, obviously, if you needed higher resolution, higher accuracy, you would go to a more expensive product. You would go to Creaform's, let's say, HandyScan or Metroscan. But this is priced much lower. Why pay for something if you're not going to need that accuracy? They don't want me to exactly mention the price. Let's just say it's the price of an inexpensive subcompact car, and that gives you about the price of what the GoScan 3D is. So once again, very fast, very elegant little tool, well designed, very ergonomic. Again, from our friends at Creaform. If you want more information on it, there's a link at the bottom. That'll take you out to the information page on the GoScan 3D. There's also a link if you're interested in how white light scanning works and how the dynamic referencing, that I don't need to use a jig or a fixture. There's also a link to a really good technical article on that again. So again, thanks to Creaform for sending us the GoScan 3D. Back to you, Mike.
Right. Good job, Dirk. Yes, Creaform's GoScan 3D portable white light scanner. And for more information, you can check that out right below the player page right there. A nice job by Dirk. And thank you, Dirk, and thank you, Creaform, for sending that on to us. Well, thank you all for being here with us today. And of course, we want to thank Dr. Zhou of Ford and Mohan Ponnudurai of Sparta for joining us as well. And one more thank you. We want to thank our sponsors this week, TÜV Südamerika. Got 60 minutes? Want to learn more about how your company can benefit from a quality management system? Check out TÜV Südamerika's free QMS webinar series covering more than 25 topics from industry experts at www.tuvamerica.com/QMS webinars. You can also click on the banner ad just below, or if you're watching, just to the left, just to the right of the player page right down there. Okay, that's it for this week. So,
yeah,
Dirk,
great show. Yeah, and once again, thanks to Creaform for sending us our first ever 3D scanner.
That's right.
We use on the show. That's pretty awesome.
That's right. We like that. And send us more Tech Corner stuff if you have them. Good ideas. Email us at QDL@qualitydigest.com.
There you go.
Let us know. All right. Well, that's the show. Thanks again for joining us. We'll be back next week with another week of Quality Digest Daily and another show of QDL next Friday. So we'll see you then.
That's right. So long.
Bye.